So another way that helps remember this formula is you find the derivative of the first functions multiplied to the second function minus the derivative of the second functions multiplied to the first functions, and then you divide by the second derivative, divided by the derivative of the second functions, or divided by the second function square. So just take g of x and square it. And the numerator looks similar to the product rule. However, it's a minus instead of a plus. And then you also don't forget divide the numerator by the denominator, which is the g of x squared. And again, we can only find this derivative when g of x is not 0. And again, this rule can be proven using the definitions of the derivative, using the limit process of the derivative. And you put it in here, you put the quotients f of x and g of x in here. And again, you do some algebra tricks to split this 2 into the 2 different functions. And then from here, you can evaluate the limits separately to get to the result of the quotients, the derivative of the quotients of g of x, f of x, and g of x. Again, the derivative of f of x divided by g of x equals to the derivative of f of x times g minus the derivative of g of x times f divided by g of x squared. And again, we can find the limits of g of x plus delta x equals to g of x because g is to be given to be differentiable and therefore continuous. So that means you just plug 0 into here to get g of x. So knowing the quotient rule, we can try to find the derivative of the functions in example number 7. Again, you want to find the derivative of f of x, and also you want to find the derivative of f of x when x equals to c. Okay. If you look at these functions here, is clearly a quotient. So we have to use quotient rule, and the quotient rule is saying the derivative of this function f of x here equals to the derivative of the top. So the top function is 5x minus 1. Okay. And you multiply to the bottom function, which is x squared, minus the derivative of the bottom functions x squared. And then you multiply by the top functions x minus 1. And you take everything divided by the bottom functions square. Okay. So then the derivative of 5x minus 1, now you can use the constant multiple rule and the power rule to take it as 5, and the derivative of 1 is 0. So the answer for this part here is just 5, and multiply to x squared, which is the bottom functions, minus the derivative of x squared now is 2x times 5x minus 1 in parentheses, divided by x squared. Square is x to the 4th. Okay. If you want to simplify it a little further, you can just distribute it in here and then simplify the numerator. So you have 5x squared minus 10x squared give you negative 5x squared. Negative 2x minus 1, which is positive 2x over x to the 4th, right? And then you can simplify it a little further. You have x here, x here, x here. You can divide every term by x to get negative 5x plus 2 over x cubed. Okay, so you just cancel one of the x term from each of these terms to get negative 5x plus 2 divided by x cubed. So this is the derivative of these functions. All right, again, in order to find f prime of c, and c is 1, so f prime of 1 will be equals to -5 times 1 plus 2 divided by 1q, which is -3 divided by 1 is just -3. So this is saying the slope of the tangent line of these functions when x equals to 1 is -3. So next questions. Again, you have a quotient, then you're just going to use the quotient rule, and it's saying take the derivative of the top, multiply to the bottom, minus the derivative of the bottom, and then multiply to the top. Take everything divided by the bottom functions square. So that will give you derivative of each of x, just e to the x times 4 square root of x. Okay, minus you have 4, which is this constant multiple rule, and the derivative of square root of x is 1/2 square root of x by the basic. This square root of x is one of the basic functions, and multiply to each of the x divided by. So you have to multiply, take 4 raised to 2 is 16 square root of x squared, which is just x. All right, so this is the derivative of the functions using the quotient rule. And again, if you want to find f prime of 2, you should plug 2 into all the x's. So e to the 2 times 4 square root of 2 minus 4 divided by 2 square root of 2 times e to the 2, and then everything divided by 16 times 2 should be 32. Okay, and you don't have to simplify it. That should be good. So this is, you can use a calculator to find, to evaluate this, to do these computations, but again, and you can simplify a little further, but again, it's fine to leave it this way. All right, once that we learn the products rule and the quotient rule, then we can use the those two rules in order to find the derivative of some trigonometry functions that are not sine, cosine. For an example, if I want to find the derivative of tangent of x, and I know that tangent is sine over cosine, right? And I can use the quotient rule to find this derivative. And the quotient rule say you take the derivative of the top, multiply to the bottom, minus the derivative of the bottom, multiply to the top, and divided by the bottom functions square. Okay, so what is the derivative of sine? It is just cosine times cosine x. What is the derivative of cosine? It is negative sine times sine of x over cosine square of x. And this is cosine square plus sine square over cosine square of x, which is 1 over cosine square of x. And what is cosine square? Is should be secant square of x. So this is how you find the derivative of tangent of x equals to secant square of x, which is what you found here, what you have here. So using the same process for cotangents, cosecant, secant, you can find the derivative of these 4 trigonometry functions using quotient rules and product rules. And in this class, you can just use this result when you are trying to find the derivative of any of the functions. You don't have to derive this formula again. All right. Let's look at example number 8. In example number 8, you have quotients and you have cosine and the tangent functions. But again, if you have quotients, then you have to use quotient rule. If you have to find the tangents, the derivative of tangent, you can look at the table to find the derivative of the tangent. So let's find the derivative of f of x. F prime of x here is going to be derivative of 1 minus cosine of x. Okay, multiply to tangent of x minus derivative of tangent of x and multiply to 1 minus cosine of x, and everything divided by tangent square of x. So this will give you, change a different color. It will give you what is the derivative of 1, 0. What is the derivative of cosine? Negative sine, but negative cosine, that will give you sine times tangent of x. Okay, the derivative of tangent of x that we just found earlier, which is secant square of x, right? Times 1 minus cosine of x. And everything divided by tangent square of x. You can leave it this way. You don't have to simplify it. I don't think it can be simplified any further anyway. All right, next example. So you have these functions here, right? It's a simple functions. It doesn't have any products or quotients, so you just need to use this one here. You can root 4 of x can be rewritten as x1 to the 4th. Then you can use a power rule to find the derivative of these functions. Okay, plus 6. What is the derivative of cotangent of x? The derivative of tangent of x is secant square. Then the derivative of cotangent of x should be negative cosecant square if you look at this table here. And this should be your answer, right? You can't simplify any further. The last one here is you have quotients, then you have to use quotient rule. So I have to use d over dx of x squared e to the x plus 3 sine x. Okay, and then multiply to the second functions. Subtract the derivative of the second functions, 2 times square root of x plus 1, and then you multiply to the first functions or the top functions. And I want to put the bracket here just to make sure that we know these are the two different things. And again, everything divided by 2 square root of x plus 1 r squared. And we'll see what is the derivative of the top here. So in order to find this derivative, you have to use the product rule, right? The product rule says you take the derivative of the first functions, which is 2x times to the second functions, plus the derivative of the second functions, which is just e to the x times x squared, plus, oh, I'm running out of space here. Let's move down here. Should have left more space for this problem. It's fine. So down here. So you say 2x e to the x, right? Plus e to the x times x squared is a derivative of x squared times e to the x. So the derivative of 2x, derivative of the first functions multiplied to the second functions, plus derivative of the second functions multiplied to the first functions. And then plus derivative of sine is cosine. Okay, and this everything here multiplied to 2 square root of x plus 1 plus minus, so I move this thing down here, so minus derivative of 2 square root of x is going to be 2 over 2 square root of x. Derivative of 1 is just 0. And I take x squared e to the x plus 3 sine x. And remember that, so this is just the top, and you take everything, you divide it by the bottom here, right? Which is 2 squared is 4. Well, I don't think we need to distribute it. Just keep it as a square. It's gonna 2 square root of x plus 1 all square. So this here should be your answer, your final answer. So your final answer, f prime of x, is gonna be this. Again, the orange, the red part is the numerator, and the blue parts here is the denominator. And this is how you find the derivative of these functions. You take the derivative of the top, right? Multiply to the derivative of the bottom. Take the derivative of the top here and multiply to the bottom functions, minus the derivative of the bottom functions multiplied to the top. And in order to find the derivative of the top here, you have this functions here is the product. So you have to use products rule. Okay, and up here you use quotient rule first. And in order to find this derivative of this, you use the product rule, saying that you take the derivative of the first functions multiply to the second, which is 2x multiplied to the second functions, plus the derivative of the second function, which is just e to the x, multiplied to the first functions. And you plug it in here, right? And then you take this and you take the derivative of sine of x, which is just negative derivative of sine of x, which is just cosine of x, and you multiply to 3. And then you take this whole thing multiplied by 2 square root of x plus 1, which is the bottom functions, minus derivative of the bottom functions here, which is 2 times square root of x, which is 2 divided by 2 square root of x, because the derivative of square root of x is 1 over 2 square root of x, plus derivative of 1 is just 0. So this is the derivative of the bottom functions, and multiply to the top. And you take everything divided by the bottom functions square, which is what you want to find. And the last part of this sections is about high order derivative, right? So, and just want to talk about the notations and higher order derivative. So we've been finding the first derivative of a function's y prime or f prime of x, dy dx, df of x dx, and dyx, right? And then once you have the first derivative, you can take the derivative of the first derivative to find the second derivative. And these are the notation for the second derivative. Once you have the second derivative, you can take this derivative of the second derivative to find the third derivative, and so on and so forth. So you can find the nth derivative of the functions, and these are the notations for the nth derivative of the functions. Okay. Once you go up to 4, then you should have parentheses around the 4 just so people know that this is the notation for the derivative of y. Is the fourth derivative of this function f of x or this function y. Okay. In order to find the derivative, the next derivative, you just need to take the derivative of that derivative to find the derivative of the next one.